Welcome back to Astronomy 1, quickly becoming the greatest science class in America. We explore not just what people think about the solar system, but also what they used to think and what they might think next. And before we get going, Caleb, did you get the final project? Can you access it now? You didn't check. All right. Has anybody been able to access the instructions? We're all good? All right. And Liv says we're good to go. All right. Otherwise, I want to finish up a little bit about moon colonization today, very briefly, and then we're going to dig into Mercury and Venus. And they're actually really fun planets to talk about because people across history have cared more about them than any other planets, as far as I can tell. They do a really interesting dance in the sky, and so people have told incredible stories about them. So I want to get into that a little bit. And talk a little bit about the exploration of those planets, although we know shockingly little about either one of them. Mercury being incredibly, blisteringly hot, no atmosphere, very difficult place to visit, and Venus also being, a complete overpressurized gas house that's very difficult to visit as well. So we will tear into it. But first, what do you guys think about the moon from last week? Thoughts? All right. Yes.
I thought when we talked about the Artemis project, about the future plans for building that as basically our launch platform for further space exploration. I found that really, really interesting. I actually went home and looked it up a little bit, and a lot of headlines I was seeing was basically so they delayed Artemis. Basically, a lot of the discussion I was seeing was people asking questions like, "Why are they delaying it? We've been in the moon before. It shouldn't be that hard."
They did do the first one, though, right?
Yeah.
Yep. Stuck some mannequins in it and stuff. I did read also after I was last week. I think one of the things I said was it's weird that Elon's not working on the moon. I guess they're building the Artemis 3 rockets, SpaceX's. So that checks out because it seems like it'd be a great launch point to test out all of your systems. Yeah.
I thought it was interesting that we got all that information from Germany.
Oh yeah. If you don't know about that, was it Project Paperclip who said that? You said that last time. We read about that? Yes, the spoils of war, right? It's pretty bizarre. A lot of technology came out of World War II for better or worse. Probably for worse, but what are you gonna do? What was the other thing you said, Caleb, about the people being like, why the heck, we've done this before, why is it so hard? That's a really interesting question I haven't been able to get to the bottom of either. Very different computer technology back then. From what I understand, a lot of the revolution in computing came from that program. Just kind of, people were not used to using computers at all. There was basic computers in the military for calculating bomb trajectories and stuff, but it was really primitive, and so the space race really kicked it into high gear. But, so yeah, they were using vacuum tube technology and all sorts of bizarre stuff back then that we don't mess with anymore because we have the transistors. So I wonder if there's an explanation in there about the transistor and just about updating this for a digital environment. But I don't know. What do you guys think? Why is it so hard to go back? Yeah?
Okay, I didn't even think about this. Now that you've said this, I'm confused about this a little bit. Because our technology is better, it makes sense that it would be easier to go back. I wonder if they got really lucky the first time. I mean, they had it very well calculated and everything, and they did the best that they could, but I wonder if it was also luck that played into it a bit, because now they want to be we want to be as safe as possible. But I wonder if they were felt the pressure of the space race and really wanting to get to the moon, and they didn't necessarily know that whether or not their technology could do it.
I mean, they had some tragedies too. I don't know the numbers off the top of my head, but one of the spacecraft burned up in a test mission when they're overpressurizing the cabin, right? It was like an oxygen fire, basically. So you got to think these high oxygen environments, you have the slightest spark inside of that capsule, and you get roasted. So that was bad. And then Apollo 13 too. I don't know if you guys know about that. What was the last mission to go to the moon? Somebody tell me. I don't know. It was in the teens for sure, but Apollo 13 was a near disaster for sure. And they basically got home by the skin of their teeth. And so, yeah, I think that's a good point. And the same thing happened with the space shuttle program too, which we don't really get into in this class, but the space shuttle program was, I think there was like 20 something missions, and was it I think two of them crashed. It was not a very good percentage rate, honestly. And the funny thing is, when they were proposing the space shuttle mission to Congress, they told them there's a 1 in 10,000 chance of failure. And so, yeah, do the math. Even if it's 2 in 20, right? It's like 10% failure rate. It's not very good space. It's not a very good technology. Like if you were going to get on a plane to go visit your family across the other side of the country, and it was a 10% chance you weren't going to make it, you'd probably either walk or ride a bike or something else, right? Take a car. Nolan.
Is it possible that like a reason why it's hard to do moon exploration is just because it's just so expensive now? Like everything is just so much more expensive. Or
Do you think it's more expensive now?
A little bit what I was seeing is that it's not more expensive, it's actually cheaper to do it now, but NASA, who is funding it, gets so much less funding from the government than they used to.
Oh, really?
That was, during the Apollo missions, that was during the Cold War.
Mm.
And that's going to the moon was like a whole political thing to beat the Russians.
Mm-hmm.
So they got a ton of funding. Now they don't have the same. So it's like, it kind of is a financial thing, but it's not because it's more expensive, it's because they don't have as much money.
Interesting. I was actually shocked when I was reading a bit about this, how cheap it was compared to just some other massive projects like the highway systems and just some random things. I don't know. There's I mentioned the mega projects Wikipedia page, quite entertaining. Sometimes I just read Wikipedia before I go to bed at night. It's just so fascinating to just surf around and find out random stuff. But yeah, it was surprisingly not expensive, right? What did we say? Like the equivalent of each American buying a pizza for 10 years or something like that. So not that big of a deal. I think the motivation is probably a huge part of it, though. It was like we have to, in some sense, we wanted to not just show the Russians who's boss, but I think that another like kind of darker side to this is the exact same technology that's used for these Saturn rockets is the same one that we use to launch nukes in the event of a nuclear war to Russia, right? So it's like it's not just arbitrary, can we do this? It's like, can we work our rockets really, really well? And that's kind of scary, but that's the world we live in, unfortunately. Or, there hasn't been a nuclear war, which is kind of crazy, actually, despite all these nukes lying around. All right, what other thoughts? Anybody's going to make me call on some people? Hi. Yeah, David.
I thought it was interesting. I think you were saying too, just to judge the distance from the planet, we are just like the light interference that the planet makes. Was that last lecture?
I have no idea what you're talking about yet.
Oh, gotcha. My note here says it says look for chemical by light interference.
Oh, yeah. We did talk a little bit about searching for life right at the beginning. That's right. Yeah, searching for life. So far, not super successful, but that's the idea. That's the hope, is that we'll be able to pull that off. I mean, you have to wait for finding planets is really tricky because you got to look for a slight dimming of a star and rule out a bunch of other stuff. It's also, by the way, I didn't even mention this, but the stars, like the orbital plane of the planets in other star systems, isn't just aligned with ours, right? So most of them are kind of like Saturn, probably, like they're turned on their side sometimes. So you're looking at a tiny portion of solar systems where the planets are going to be just in line with the star with respect to us, right? So you've already narrowed it down. It's very tricky to find these things, in other words.
We also told us to look up the Star Maker.
Oh, did you? Oh, you didn't? Oh, come on. Did anybody look up Star Maker? Yeah? What do you think? You read the first chapter?
Oh, I just found it.
You just found it. Read the first chapter, at least. If you're not hooked, let it go. But it's pretty fascinating. We just released a podcast about it today. It's a really, really awesome book. All right, what else? Yes, Macy, right?
Yeah.
All right.
I didn't know that. So I never really thought about it before, but the reason why we want to build stuff on the moon is because of the low atmospheric gravity. I didn't like ever think about like, oh, you can just toss things into orbit. So I thought that was pretty cool.
I think it's going to be happening in your guys' lifetime for sure. It's the next logical choice. It's like millions, and it's like what, 250,000 kilometers to the moon, but it's like tens of millions to Mars. So it's a nice little, what do you say, training wheels kind of situation. Yeah.
In the past simulations, how fast they actually happened, because you had it up with all the dates, and it started December 1968, and that's when my dad was born.
Yeah, it's
And to
nuts.
see everything done before he was even 10 is crazy.
It's really, really crazy. I mean, I think you got to be honest, you got to go all the way back to the Nazis launching rockets at London, basically. Because that's when the basic technology was being developed for the first time, right? But still, that was what, 1940s? It's like, yeah, it's a couple decades even. It's pretty crazy. And by the way, people were like a couple of bicycle engineers from Ohio were, flying around on like stick planes about, what, 30 years before that? It's completely nuts how fast all this has unfolded. That's the question is like, and now we got AI to deal with and freaking Instagram and TikTok and everything's going very, very, very fast. Nolan and then Orlando, yeah.
Did you ever see this? It was like a Discovery documentary. It was like a 3-part series. It was called like 2048 or 2058 or 2060 or something. And it basically had a few like famous, I guess, scientists come on and talk like what would the world actually be like and like what's being worked on. This was I think in early 2000s.
Yeah, those are always fun.
Yeah.
What did they think? We'd have flying cars by now?
Well, I mean, they mentioned AI and.
Oh yeah.
By 2025.
Yeah. Oh yeah, we talked about AI for a long time last week. That was good. I don't want to get completely derailed by that, but yeah. Hold on one second on that. Hold on the AI thing. Yeah.
Question just popped in my head.
Yeah.
Talking about how fast technology kind of came to be.
Mm-hmm.
But we've kind of reached a bit of a bottleneck. Maybe I'm just like looking in the community about what's being built and what's not. But like these days, technology it's advancing, but it seems like things are slow.
Yeah, I think there's a really good case. It's interesting you make that observation. I think there's a good case to be made about that. I have a friend, I guess you could call him that. I don't know. I know. I don't know what to call this guy. Anyways, he's been on my podcast. He's a chip developer in Silicon Valley. He runs a bunch of multi-million-dollar companies, and he's got really interesting perspectives on. He's worked for Elon. He's worked for Apple under Steve Jobs. Like he's been at Tesla. He's been everywhere. He built the first self-driving car systems at Tesla. He's kind of a badass. But he has this really interesting perspective because all of these companies are unique because they're sort of helmed, like Apple, if you think about it, Tesla, they're helmed by these kind of crazy geniuses, right? And they can get a lot done because they're these single-headed, like crazy geniuses. But in these other companies that become these massive, over-bloated, like bureaucratic monsters, you think about like Microsoft, right? Like, what has Microsoft done? Like they came up with a software back in like 97 or something, right? And they're still like kind of clinging on to stuff. But it's like, it's very hard to keep innovation going inside of a large bureaucratic system. And so a lot of these like Google is having the same problem right now, honestly. They were really good at this search thing when it was like 13 people working in like a warehouse back in San Francisco like 20 years ago. And they're having a really hard time keeping up with anything else because they don't have the flexibility to just try crazy things and lean into them, right? Everything's got to go through like 20 subcommittees. And this is so with respect to like space exploration, but science in general, there's a huge case to be made that science in terms of like really groundbreaking theories has really ground to a halt in the last 20 years. Now, I was always told like, well, that's because we've solved everything and there's just not that much low-hanging fruit to pick anymore. And I'm like, I kind of bought that when I was like young and a little bit stupider. But the more that I have looked at things, the more I realized that if you're the kind of person who's really, really free-spirited and outside-the-box thinking and like the kind of people like some of these super bosses we've talked about in this class, like Huygens and Newton and these people, you're probably not going to be too at home teaching in a university, like a large research institution where you sit behind a desk and have to beg the government for money with most of your time. Like, you guys probably don't know this because it's not a huge research institution, but if you go to grad school or something, you want to become a scientist or whatever, you're going to have to basically join a lab. And the lab is run by a guy or a lady who basically spend all of their time begging for money. Like that's what you'll end up doing. That's the end goal of becoming a scientist in some sense, is like you look at these DARPA grants, these DOE grants, whatever, and you try really hard to imagine how you could fit your interests into one of those slots on this list. And so in some sense, there's an argument to be made that we've squeezed a lot of the creativity and the creative people out of these disciplines, right? And in so much as the tech landscape is dominated by these massive monolithic entities like Google or, I don't know, Oracle, like these huge, massive behemoth companies, there's not a lot of room for creative people to get involved in them, and therefore they just kind of like lumber around and don't really make a lot of innovative progress. So yeah, in some sense, technology is going really fast, but in some sense, yeah, the major innovations have slowed down. So it is kind of interesting. There's two sides to that coin. And like, I think the jury is still out. We talked about it last time. Maybe we can get a few thoughts on that. But you talk to AI researchers, and you know, how about you just do your own AI research? You play with AI, right? Like you play with ChatGPT or something, and like you kind of sometimes get the feeling like, well, maybe this thing's just gonna stay stupid forever. Like I'm always having to fact check the thing. I'm like, hey, I think you're wrong about that, and it's like, oh, I'm sorry, you know? Right? And it's like, am I gonna be having to do that like 20 years from now still, or like maybe it'll have more information to draw on, but in some sense, I prefer Wikipedia to get my information, like my starting information from, because at least I can follow references, right? If ChatGPT tells me something, I'm just like, well, I don't know, like, where did it get that? Maybe it just made it up. But then again, when I was, I'll never forget one of the first labs I worked in. So like 20 years ago, Wikipedia was like a complete heresy, right? Like it was a garbage website that nobody would trust with anything. And I saw a kid give a presentation. He was trying to do a rotation and join a lab. And he referenced Wikipedia, and he basically got like thrown out of the lab for it. And I was like, whoa, because the boss at the time just like had this perspective that Wikipedia was just this completely unreliable website and so forth. And it's probably like 90% accurate at this point. It's not bad, probably better than ChatGPT. So I don't know, these things can evolve. What do you guys think? How do you feel about the AI revolution? Is the general intelligence coming for us? I mean, we don't have to go down the rabbit hole with this. Let's not go too deep. But if anybody had any thoughts after class, or after the last class, I would want to hear them. Yeah? Fears? Yeah? What do you think, Caleb?
AI engineering class.
Oh, cool.
Right now.
Heck yeah.
One of the things we're doing is like the current work assignment we're working on is we have basically a bunch of different AI. We basically make like a team with them. You have one AI who like gives the directions to the other ones, and they all do it. And I mean, it might just be like current models and whatnot, but they're really bad. Like, so our thing right now is we're having the AI do research for us.
Okay.
And they're not the best at it. So you have to, like, part of what we have to do is like give them extra tools to better search the web and stuff.
Okay.
And even then, it's like by the end of it, the reports that they make aren't the greatest. I don't know. And that's what you get me thinking about here is like, there's a lot of things that AI is not that good at yet.
Yeah. That's the yet question is huge, right? By the way, what department is that in?
The computer science.
Interesting. Cool. Is that a brand new class?
I actually don't know when they started it.
Okay.
I know it's been around for at least 3 years.
Very cool.
It changes every time we teach it because, you know.
Everything's changing. Yeah. I saw a hand over here. Yes, Doris.
I don't know a lot about AI or like what the current state of affairs is with it, but what would be like within that community, like what would be our like best possible outcome of having it? Like what would be the
That's an awesome question. That's one I always ask these people too. So I'm like, what's the end game here? Like, do you want to create like godlike entities that displace our utility, or is it just a super tool like Batman, like some utility? Maybe we are. It's weird because a lot of the AI researchers I talk to don't seem to really care about that. It's kind of a puzzle to them, which I totally respect. I understand like playing games is fun, but it's like, what is this game all about?
I think specifically, I thought about AI in manufacturing. If you can like make a manufacturing chain, like like t-shirts, apples, whatever, and when there's a problem with the device or something, it can self-analyze, self-fix, and order a part that it needs without someone having to go in there, see what's wrong. You know, it just makes it way more efficient when things do go wrong.
And a lot of that's in place, right?
Through that, that's being used now. So.
It's being used. I mean, that brings that's the point too. We don't need to rehash completely what we talked about last time, but embodied, like an embodied AI system would certainly be a little bit more fearsome than just something inside of a computer that you chat with, right? It's like once these things actually have bodies and they can do stuff, that's going to be a totally different landscape. But we'll see if we get there. All right, cool. That's good to hear your guys' thoughts. Let's keep talking, but let's move towards talking about Mercury and Venus at least. But first, I want to say just a couple little things that I didn't get to about the moon. So one of the really, in addition to it having no gravity, which makes it a really nice place to build stuff, it also has a ton of, is this even the right slide? No, let's do this one. It has a ton of really good stuff on it, right? A lot of good material. So it has a lot of rare earth metals, which of course are the things that they're digging out of the Congo right now. It also has, people think there's a fair amount of water on the moon too. And water, like we said, it's really good for building rocket fuel. You can also get oxygen out of it, which is good because you can breathe it. So there are a lot of private interests in the moon, but there's also just this general sense that it's a good launching place to get over and make it to the next place, make it, further into the solar system. Also, helium. Do you guys know about the helium crisis? Yeah.
Okay, I don't understand the helium crisis.
Okay.
I don't understand how we have less helium. Because when I was a kid, you get balloons as a kid, and it's like, oh, their helium is scarce.
Mm-hmm.
I just don't understand how you can have less of an atom because it's still on Earth. Like, how is it not? What do you mean there's less helium?
Yeah. Well, it turns out that if you think about it, the Earth sort of sorts itself. I said sort of sorts itself. That was kind of a mouthful. Sort of sorts itself by heaviest elements, right? So the heavy stuff is underneath us. The lightest stuff is above us. And that means that the light things tend to accumulate really high up. So we're losing hydrogen all the time, the lightest stuff. Helium's the next lightest stuff. And so whenever helium gets released from underground or from wherever the heck it hangs out at, it's gone at some point. It gets blown off by the solar wind and all of that stuff. The moon, on the other hand, accumulates helium from the solar wind. So there's a fair amount of helium on the moon, and people are really excited about that. I don't know what the projections are for when we're going to run out of helium or something. Obviously, we're not that far out of it because you can fill up kids' balloons with it, right? So it's not that big of a crisis. I think that those headlines, whenever they came out a few years ago, were more just pointed out the fact that it's a non-replenishing resource here on Earth. And it is dissipating through the atmospheric losses. So anyways, the moon has helium. It's actually really important for some technologies that we depend on all the time. In particular, MRI machines use it. So if you need to get a scan at the hospital or something like that. Fusion also, fusion's, I don't know if we need to crack open that can of worms today, but fusion, some of the standard fusion designs use a lot of helium, and so it's thought that it'll be really necessary for the next generation power reactors. So what else? So a lot of the things that make hanging out on the moon really difficult are going to be really, really difficult on Mars or wherever else we go. So it's a good test case. It's got a huge range of temperatures. So the surface temperature can vary from, let's see, minus 279 degrees Fahrenheit to 100 plus degrees, right? So it's very, very wide range. That's very uncomfortable. The radiation exposure, because it has no atmosphere, no magnetic field, your DNA is not going to be very happy there. The moon dust itself, I guess, is really, really caustic, so it has a tendency to seep into. Has anybody spent much time in the desert before? It's a nightmare, right? Anybody been in the military? Yeah? You been overseas? The dust is crazy, huh?
Yeah, I was in Germany.
Oh, you're in Germany. Okay, sorry. I'm like, yeah. All right. That's cool though too. yeah, the dust is a nightmare. So especially during these recent military campaigns, you'll hear these people who are flying helicopters or tanks or whatever, just basically getting this stuff in their engines like everywhere. It's an unbelievable nightmare. And so it's basically the same thing on the moon, but even finer dust that's going to seep its way into everything. And basically is just a huge chaotic problem. And it's going to be the problem on Mars as well. The other thing, gravity. Do we need it for our bodies? That's a really interesting question. People have lived in the space station for, I think, year plus, and they're okay. It's very difficult for them to transition back. They obviously have to exercise a lot while they're there. Plants grow in a really strange fashion. You guys ever seen the zero gravity plants before? They do grow, but they don't grow to look. Yeah, you should Google some images of that at some point, like a zero gravity tomato or something like that, or lettuce. It's very strange. So people don't know really the effects of low gravity and what that's going to do, but it's a good place to figure it out, right? This is one other thing I want to show you guys. Somebody asked about the treaties with the moon. So who owns the moon exactly? Let's see here. People who have not signed the treaty are in gray. So I guess I was wrong about that. Very few people have signed it. The people in blue have actually signed the treaty to keep the moon completely let's say neutral, so people can't just like divide it up and own it. But basically all of the major superpowers have not agreed to any such thing. So it's going to be a little bit of a race, I think, at some point once those technologies become actually viable. All right. Anything else to say about the moon? Yes.
What are the tallest mountains on the moon? Are there mountains, or I guess
There are, yeah. That's a good question. I don't know what the tallest ones are. They're definitely these kind of rounded profiles. They resemble like the really eroded mountains on Earth. Like if you see some of the stuff, actually, we have a lot of really ancient dead volcanoes out here in Oregon, especially on the coastal range. But yeah, I don't know. That's a good question. I don't know. I don't have a number for you. They're not as, so we'll compare it to Mercury. Mercury has these really really strange mountain ranges that are kind of like linear, like long cliffs, and the moons are very different, which seem to be mostly from some sort of impact that's been eroded over time. Yeah, we don't need to go through that. I think I talked to you guys a bit about the impact history, which is really, really bizarre. I don't know how much I want to beat this horse. It's a little bit dead, but the timing of the impact is really bizarre. In order to make it fit into this timeline of the history of the solar system and the Earth, you basically have to have all those impacts happen one geological day many billions of years ago, which is quite interesting. Except, yeah. All right. Any last thoughts about the moon before I move on? We can get to Mercury here. Yeah.
I don't know if it's really relevant, but I was talking to my friend who's an agriculture major, and he was like researching growing potatoes in moon dirt.
Oh, cool.
Do you know anything about that?
No. I neither know anything about potato growing or growing it in moon dirt.
Like,
Where did he get moon dirt?
I don't know, just stuff in the moon. He's an
Okay.
agriculture major,
Interesting.
but
I guess they do have tons of moon rocks sitting around somewhere.
do they just go and collect it and bring it back?
I guess so. There's a bunch of them. I actually knew this guy. Another weird, I don't know if I'd call him a friend, but a guy I know. He used to work at NASA, and they had this like warehouse full of moon rocks, and they weren't using them for anything. And so he thought he might just take one home, and he thought it would make a really nice gift for this lady that he had a thing for. And he ended up doing like 10 years in prison for it, actually, as a result of it. Yeah, so that's pretty sad. He's actually a really good physicist now. He spent all that time learning mathematics while he was in jail. True story, true story. I won't call him out by name, but you guys can, there's a book written about it. You can check it out. Yeah, so there's a lot of moon rocks. So I guess those experiments are totally possible. Yes?
So it kind of seems that like the bigger system of it. But kind of
Yes.
cosmology, is there tectonic like plate stuff because there's like volcanoes and stuff?
Yeah, not apparently. I don't know. There are these weird escarpments, these weird like line like cliff things, which I think the best NASA explanation is that they're from some sort of like thermal shrinkage or expansion. Yeah, we'll get to that in a second. But no obvious tectonics, and you've hinted at something I was going to get to in a minute, but. Yeah, Mercury and the Moon basically have very different interior structures, right? So it's thought that the core of Mercury is almost the same size as our own core, and there isn't much else to it, actually. So the core is pretty enormous. It's almost the size of the Moon, actually. But the weird thing is that, well, Mercury has a magnetic field, but it's significantly less than the Earth's. Now, is that because it doesn't have a solid core to amplify it like we do? Is it because it's not as churned up as ours? It's hard to understand. It doesn't have obvious volcanism on it too. So again, if our explanation for our own magnetic field has to do with these convection cells and so forth, why don't we see that on Mercury? I feel like there's just a lot to this story of magnetic field production that's yet to be uncovered. All right. So both of these planets, have you guys ever seen, I'm kind of talking about Mercury and Venus at the same time. The reason that they're grouped together like this, and I think they're grouped together in your textbook too, is that they're both interior to us, right? Which makes them have a unique sort of dance in the sky. So have you guys seen Mercury or Venus? Yeah? You can see them for the most part. Now, Mercury, if you imagine it, what's really interesting, and Venus is the same way, is that part of the time you see them in the east, and part of the time you see them in the west. So this really has to do with whether it's on one side or on the other. And the result of it is that you have an evening star version of it or a morning star version of it. It's basically going to rise, or it's so close to the sun, in other words, that it's going to kind of trail the sun on either side of it, if that makes sense to you. So this became like a real, oh, here's a nice picture of it. You can see Mercury. You can imagine the sun setting, right? The sun's over here, and all these planets are in the line of the ecliptic. And Mercury is very close to the sun, right? And Venus is close also. Can't see Venus in this picture. That's fine. But Mercury is going to basically spend very little time in the sky because it's so close to the sun. It's going to kind of be wherever the sun is. So if you watch the sky for a long time, like the ancient peoples did, Mercury seems to be kind of flittering in and out of the sky very quickly, right? It's only there for a few days and it's gone. Whereas something like Jupiter is going to hang around for a long time in the sky with respect to something like Mercury. And Venus also has a sort of predictable pattern to it, a little bit slower and longer. The result of that is that people built these really interesting they really saw themselves, some portion of their psyche in Mercury and in Venus. And they told very interesting different stories about it. So the famous, like obviously the word Mercury, this comes from the Roman tradition, right? Hermes, I guess, is the actual god associated with it. And Hermes is, of course, the messenger of the gods, right? He's got these winged feet and kind of flies around, which is really interesting from like a psychological standpoint, because there's something that connects all of your different emotions. Like the Roman gods or the Greek gods or the Sumerian gods can sort of be thought of as these personality subsets of yourself, you know, like these things you know how to do without thinking about them, like fall in love, for instance, or get pissed off, right? That's like the god of rage and the god of love, right? You kind of, there are these emotional programs that exist within you. Whereas Hermes, this, and you see this in all the different religions. We'll talk about the Sumerian one in a second. The Sumerian version of that, or the Canaanite version, it's the god of wisdom, right? It's the kind of conscious process that overlays your emotions that allows you to kind of control them in some sense, right? It's actually intelligence, if you want to think about it that way, is the way that people thought about Mercury. So that's kind of interesting. So it's the go-between of all of your different emotions in some sense. But one thing that everybody seemed to come back to all around the world was that, in particular, Mercury and Venus seem to disappear there in the evening for a little bit, and they go down under the horizon for some period of time, and then they reappear in the morning, so morning and evening. And everybody started telling these stories about these deities descending into the underworld and having these trials and then reascending either as a new version of themselves or as some completely new deity, right? And I think this is fascinating, not only because it appears in almost every culture. By the way, some cultures were more obsessed with, like the Mayans, for instance, are way more obsessed with Venus than they were with the solar calendar, for instance, right? This was such an important dance that they saw happening. But you see this same story of this descent into the underworld and the rising out of it. It's really, really interesting. So why do you think that is, first of all? Why is everybody telling this story? They're not friends with each other. They're on opposite sides of the globe sometimes. Where does that come from? Ideas? Yeah, there's a couple of right answers, probably, yeah. Why do they come up with that same story? Anybody? It's like not necessarily a right answer, but I have some ideas. What do you think? I mean, one of the maybe the easiest interpretations of that would be, well, people have been burying dead people underground for a really long time, like, I don't know, 100,000, maybe if you take these Homo naledi's, these primitive hominid species, they're hundreds of thousands of years, they found these burial chambers underground for these things. So humans have been burying people underground for a really, really, really long time. Now, that's a whole other discussion, like why did they do that? But they have been doing it. So there's some sense that humans have always associated going underground with this passage into death. And I guess I would make the argument that death is probably the most difficult part of being alive, right? And I'm sure some of you have lost people you're close to, but needless to say, when we are first born and we learn concepts for the first time and people are explaining stories to us, one of the worst stories you'll ever be told when you're 5 years old or whatever is that your parents are going to die someday, you're going to die someday, and everybody you know is going to die someday, right? It's actually one of the most impossible, what would you say, challenging pieces of this whole puzzle of existence to navigate. So an argument could be made that in some sense, the goal of of these very early religions, these cults of mythology, was to help people navigate their way from life to death in some sort of orderly, peaceful fashion, right? And so this descent of the stars to the underworld, right, to where, like, basically this death story playing out, like, even the stars do it. And hey, look, they come up, right? They make it through to the other side because they rise on the other side and they come out. In some sense, there is a triumph to that, which is interesting. But I think there's something more, like, everyday and blasé about this, which is, I think, why it really appeals to all these different cultures, which is that, and you guys have probably experienced this all the time, but sometimes life deals you lemons, right? Like, you get knocked down, like your partner dumps you, like you fail some class, like terrible things happen to us all the time, right? And I think in some sense, these stories of this descent to the underworld are that experience that's being played out in our daily lives like that, where terrible stuff's happening. And hey, look, you can get through it, because if you do, then it's likely that when you rise again, you're going to be stronger than you were before you went through all of this terrible garbage that life fed you. So I think there's something about that cycle, right, which is true to our actual biological, physical selves dying, but it's also true to what it means to grow up and be a functional human being. You gotta die many, many times proverbially, like at least in a mythical cosmic sense. Like, you've gotta let your old self go in order to move on and be a better version of yourself. There's something about that cycling, I think, which these people were really keying into in their mythological religious traditions. So I don't think it's just some super silly, superstitious story. I think it captures something very fundamental about what we see happening in our lives. What do you guys think? Any other thoughts? Like any alternatives to that? It's just too common of a motif to just be some arbitrary story that's told. Yeah.
Yeah, I think it's a good point. Like, I just feel like everything we do in our daily lives is almost for comfort as well. I mean, like every 5 seconds we're checking our phones and like always like trying to distract ourselves from the next thing. So
How's that going? Yeah. God. Yeah. No, we do want. I think one way that people get comfort is by stories that we tell ourselves, right? I know I'm comforted by the stories I tell myself about the world. It could just be like the story of who I am and who I'm going to be tomorrow and stuff, right? But I think that in some sense, these myths and these religions celebrate the commonality of those cycles we go through, because you know, I don't think we've talked much about religion per se in this class, but it's like people. So they do these studies. People who are religious tend to be happier than people who aren't religious. Now, you might say like, okay, well, they're just dumb or something. Like they just don't look at the science carefully or something. And it's like, well, there's something about these stories that allows people to orient themselves. By the way, that's like any religion. It doesn't really matter which one it is. It's like pick a religion. It doesn't matter. There's something about being able to orient yourself towards the common cycles of life, right? Something about being able to see yourself as not just having a bad, man, this year is really killing me. It's like more like, yeah, this year's killing you, and it's killed lots of other people in different ways, and we're all suffering in that together, and we're all going to get through it together, because that's what it means to be a human being, is to like have things suck sometimes really bad, and then to rebuild yourself. So there's something about the commonality of it that I think these religions as a whole celebrate. And the mythologies are just ancient religions, essentially. So, and you got to think, by the way, the states, like this idea that religion is something separate from the government is very, very brand new. It's a very modern idea. For most of human history, when you see a state, it definitely has a religion associated with it. So it's encoding something cultural about the way that people should be interacting with one another too. Yeah. Any thoughts? All right. Okay, let's move on from the myth. We'll come back to the mythology when we get to Venus, because there's a little bit more to say about that story. Mercury. Anybody see Mercury in this picture? Yeah, that tiny little dot up there. Oops, there it is. You see it? It does pass in front of the sun, so it does this really interesting dance. Let me see if I wrote that down. No, I wrote it down for Venus. But anyways, it spends some portion of the year on that side, some portion on that side, and then every once in a while it goes in front of the sun. Now, we don't always see it go in front of the sun. So the last time we saw it go in front of the sun was 2019, and we won't see it again until 2032. Why would that be, even though it's going around the sun constantly? It only takes, like 50 days or something to go around the sun. Maybe a little more. Don't quote me on that. But it's tens of days to go around the sun. Why do we only see it every decade or so? Yeah.
Earth has to be like on the same side as, oh wait, I see what you're saying.
Yeah.
We would have to be in the part of.
You're close.
Is it orbit not perfectly flat?
Exactly, yeah. Exactly, yeah. So it's at a slight tilt, right? It's the same reason that we don't have solar eclipses every time the moon goes on the sun side of the Earth, right? Because it doesn't always line up perfectly, right? It's at a slight tilt, just like our moon is slightly tilted. So it doesn't line up all the time. And Venus is tragically, the last transit of Venus, same reason. We saw Venus back, I think, in 2004. We will not see it again. So I think it will be 2100 or something like that before it comes back around again. So barring any incredible AI-generated immortality devices that might come online in your lifetime, you will probably not see the transit of Venus. One time I thought, before I actually knew that fact, I saw a little, it was a couple summers ago when the forest fires were really bad and the sky was all pink, and the sun, I saw the sun like in all of its beautiful glory behind one of these clouds, and I could see like all of the beauty of the sun, like its filaments kind of streaming and everything. It was incredible. And I saw a little circle on it, and I was like, whoa, is that Venus or Mercury or something? And then I got my binoculars and I realized it was just a sunspot actually, but it was pretty cool still. So yeah, it will transit and it's not gonna do it. We'll be able to see Mercury if you have a telescope, and you don't, be careful with that though. Do not stick your eye in front of the telescope while looking at the sun. Yes, I've had some bad experiences with that before. All right, so magnetic Mercury. We touched on this very briefly, but yeah, this is maybe a better way to look at it. Well, so Mercury is the second densest piece of material after the Earth in the solar system. There's I think a kind of reasonable way to look at it is that Mercury is kind of like a core without a planet, basically. Right? If you look at the size of the core of Mercury compared to Venus, Earth, and Mars, it's like we all kind of have the same size core, right? But Earth and Venus and Mars to a less extent, we have a pretty large mantle on top of that. And of course, the mantle is variably viscous too. It's not just this static rock thing that's painted in the textbooks. It's just a more stiff version, a less molten version. So that's kind of interesting on its own face. And like I said, I think the story of the magnetic field production of all these things is one of the weirdest mysteries in the whole solar system that nobody's really nailed down from what I can tell. It's supposed to have a really ironous core. Perhaps it's not a solid iron core, so maybe that's why it's not being amplified the same as the others. Another thing that's really quite fascinating too, when we're thinking about the history of the solar system and why things are the way they are, Mercury is basically not tilted at all compared to the sun. It's basically in the sun's ecliptic perfectly. It's at 0.1 degrees of tilt. The next runner-up is the moon, which is super weird, actually. And there aren't great explanations. So you can make an argument that because Mercury is so close to the sun, that it's really tightly under the influence of the sun's gravity, and so it's kind of being pulled on more often and has this ability to line up. The moon, though, that's pretty weird, especially because the moon doesn't, first of all, it doesn't orbit our spin axis, right? It doesn't orbit around the equator. It orbits at 5 degrees off of the ecliptic, which is the sun's equator, basically. And yet the moon is one of the least tilted bodies in the solar system too. So really, really weird. And it makes you really wonder about the history of these things, especially if you think about stability as something that takes a really long time to happen. Yeah. What do I say about that? Another weird thing about Mercury, it has this pretty large eccentricity. So it's kind of this ovoid shape, and the eccentricity precesses as it goes around. So the longest point is kind of moving. It's carving out this kind of trochoid pattern as it goes. People have been fighting over why that is the case for a very, very long time. Einstein gave a mathematical explanation for why he thinks this is the case, but it's kind of a standard, what would you say? It's a darling of a physics problem. You know, I've also heard really interesting explanations, like perhaps the sun has the sun itself has some lopsidedness inside of itself with respect to density, right? This is a really interesting theory I heard recently for this anomalous precession. We know the sun is one of the most spherical objects ever, which is pretty weird by itself because it's spinning. So you would think, how the Earth is like you've probably heard the Earth isn't an exact sphere, right? Because it's spinning. That's that usually what people say, right? But the sun is also spinning. It's actually spinning faster. It takes, 20-something days to go around. It's spinning very fast considering how wide it is. It's a perfect sphere almost, which is very bizarre. So maybe the interior is deformed in some sense that the density is not even, and that would lead to an anomalous precession. At any rate, it's weird. It's also Mercury's spin compared to its orbit, so how fast it turns its day, compared to its orbit is in a perfect ratio of 3:2, which is a perfect fifth in music, if you all play music. That's another one of those strange resonances that pops up over and over. The music of the spheres. It's quite interesting. We'll keep seeing those as we move throughout the solar system. There's all these very beautiful musical notes buried throughout it. So as it rotates really slow. So a day on Mercury technically lasts 2 Mercury years, and that's something like 90 days for us, 87 days, Earth days. What else do we want to say about it? Okay, here's a picture of some of those clips that I was talking about, not in addition to the craters, right? People think these might have had something to do with it cooling as it aged. I don't know. That's a hard argument to be made if the argument is that the moon is the same age and that it's cooling as well. I don't know. It's very difficult to explain these. We'll see these escarpments on some of the moons of Jupiter too. It's a very interesting feature. Just these, stretch marks on the face of this thing. What about exploring it? So people have sent some rovers to go and check it out. The best they can do is really look at it with sophisticated wavelengths. They'll put these radar, by the way, this image I showed earlier is from some of the radar mapping of the elevations. They get really sophisticated like height diagrams of it. But it's very, very difficult, like I said, to study this thing and really give you any hard facts about it because it's just so miserable. It's unimaginable to land there and hang out. What did I say this swing in temperature was? It's insane. The temperature range is 600 Kelvin, so 600 degrees Celsius from day to night on the thing. It's just very difficult to imagine sending any kind of landing craft over there. So yeah, don't know a lot about it in terms of hard material examination. Mercury, thoughts, questions? All right. So Venus is also problematic for many of the same reasons. Like I mentioned, this is what Venus looks like from the outside. This is a radar map of Venus's surface because it has these really, really thick clouds on the thing. So it's about its surface pressure. We were talking about the potential for a thick atmosphere to explain some of those huge winged animals back during the dinosaur era a few weeks ago. And we talked about how Don Petit and his advisor were able to make the things fly with about 3 times the surface pressure on Earth, right? Which might seem like a lot, but Venus has 100 times the surface pressure that we have here on Earth. So every square inch is going to have 100 more pounds on it than you would have here on Earth. There's a fair amount of pressure on Earth, right? It's not that big of a deal if you're used to it. The problem is we're not used to it, and taking a craft that was built in our low pressure and then bringing it there and through the vacuum of space, it's very, very difficult to do. I think the longest that anybody's survived, did we look this up the other day? I think it was like a half an hour or something like that. Was it the Russians who put a craft down there for a half an hour last? I believe so. They don't last that long, right? It's kind of like it's like sinking a submarine to the bottom of a trench, some unimaginable trench on the sea that it just can't handle it. So these things eventually explode, or implode, I guess is the right word. The range of surface temperatures is also extraordinary. Venus is turning really, really, really slow, by the way. I don't have this written down right now, but its day is unbelievably long. It's longer than its year by a long shot. It's also turning the wrong direction, which is really, really, really weird. So of all the planets in the solar system, Venus is the only one that's going a different way than the others. Yes?
The shortest we last is 23 minutes. The longest is 2 hours.
2 hours? Who is 2 hours? Who? A human can last, yeah, right. I'd like to see you make it a second on Venus. No way. I bet you'd make it like a nanosecond. Just squished. Who made it for 2 hours? That's fascinating. Tell me who it was. That's interesting. So I know that they're going back. There's a mission that's scheduled to get there around 2030. That'll be quite interesting. I talked to the guy who was running that program a year ago. And they're trying to basically, like the way they're going to do it this time to get more data is they're going to descend really, really slowly. So they built some sort of parachute-like system so that they can collect all this data. Obviously, just like on Earth, the pressure is the highest down at the floor, down on the deck, and it's less pressurized up top. So you can, if you really slow your descent, you have more time to collect data. Who was it? The Russians. Venera is Russian for Venus. Yeah, it's got to be. That's interesting. Yeah, I wonder why I never even looked into this, but why the Russians were so interested. They seem to have done most of the exploration of Venus in the past. Anyway, so Venus has a special place too in the history of astronomy. We talked a little bit about Galileo revealing the crescent form of Venus. There's an argument that you can see. Some people claim they can see the crescent form of Venus with the naked eye. I don't know if they can or can't. I definitely cannot. But certainly it wasn't, the world at large did not accept it until Galileo had pointed his telescope at it. And why does it matter so much? Well, it finally resolves Ptolemy's 1,000-year theory of epicycles, because all of a sudden the only way to actually get this nice crescent shape is by having the thing orbit the sun. That's literally the only way you're going to pull off that shape. So Venus was part of the slam dunk that changed our conception of the solar system. And it's really interesting how when these big things happen, I think it was probably really painful for that transition to happen. But at the same time, people really need somebody to tell them how things work. If it could be the Pope, it could be NASA, but some people really want this story to be upheld. So that was not a change in perspective that came easily. Here you go. We were talking with Caleb earlier about why we don't see the thing. There's the incline for it, which explains why we don't see it very often. Venus is even more infrequent in some sense because it moves slower. So this was what it looked like back in 2004. And we're never going to see it again, sadly, unless we get the biotech revolution. This is, of course, in some sense, like I want you guys to consider, like, for 1,000+ years, people really believed that that the Earth was stuck at the center of this whole mess, and that these beautiful patterns were being carved out. I think this is an interesting lesson. So this is Venus. Who is this? This is the Venus and the Sun carving out this trochoidal pattern. If you frame the system based on Earth, and in some sense, part of the argument prior to this, the heliocentric revolution that we are all living under today, part of the argument was that this is just so beautiful, right? Which is interesting because, there's still occasionally mathematical theorists who are arguing for the veracity of their theories based on how beautiful they are, right? And the reality of the situation is that these kind of off-center elliptical orbits that we now believe to be the case for the solar system are not the beautiful, perfect circles or flower-patterned trochoidals that we wanted them to be for 1,000 years, right? So beauty can be a really misguiding force when it comes to understanding nature. Sometimes nature is red in tooth and claw. Sometimes it's gnarly. Venus has Trojans. We talked a little bit about Trojans before. That's kind of cool. Not everybody does. And they tend to hang out in these L4, L5 places. We talked a little bit about that. I found this little diagram, which I think might help you guys see how the L's are made, the Lagrange points. I normally loathe these gravity well pictures, but I think these ones this actually helps a little bit because you can see like the strength of the gravity in the sun, strength of the gravity with the Earth, and you can see that there's these nice little null points on the borders there, right, where it's equally tugged on by both of these, and you get little chill points where you can collect debris like asteroids and so on and so forth. So let's see here, got about 20 minutes left. Venus, another reason I think that Venus played such an important role to all of our ancestors was that it's just so bright. It's one of the most, it's probably the first star that you'll see in the sky, if we can call it a star for a second. It certainly was a star to our ancestors. It's actually so bright that we have to give it a negative magnitude in terms of apparent magnitude, right? So remember, they came up with this magnitude system. I don't think I got to tell this story, but the magnitude system was, in some sense, developed during those early years that we talked about with the lady astronomers at the Harvard Observatory. And they set up this comparative analysis way of coming up with absolute brightness, and they were actually trying to use, they were trying to standardize old measurements too that were set up. And the result was that we end up with negative numbers because the things in our own solar system turn out to be way more bright than things outside of our solar system for which the magnitude system was constructed. So anyways, Venus has an apparent magnitude of minus 4.14. It's very, very bright. So it's an easy thing to see. Let's talk a little bit about the origins of this Venus myth, which is quite fascinating, because I think all of the Western myths, at least, can be traced back to Mesopotamia. So one thing that comes up a lot in terms of whether or not the Mesopotamians understood Venus to actually have this crescent shape is that they often use this this horned god illustration, right? These kind of like horns on it, and so there's often this this thought that perhaps they were referencing the actual crescent form of Venus when they were doing this. You also see this form kind of trickle down through the Minoans to the Canaanites. We talked a little bit about them before, but it seems to be a theme. They might have also just worshipped bulls, so it might have nothing to do with that. Again, it's very hard to see. So we talked a little bit about this with Mercury, but Venus is actually the biggest underworld descent story. And it persists down through the years in that Western tradition from Sumeria. So this is the same schematic. Basically, you have this situation where Venus appears in the morning for 263 days. Then it goes behind the sun for 50 days. And then it's in the evening for 263 days. And then it's in front of the sun, so you can't see it, for about 8 days. So this is a really interesting pattern that people are watching play out in the sky. And they're constructing this descent story to mirror it in some sense. So here's a good question. Why does it go behind the star for 50 days and in front of the sun for 8 days? Anybody? It's kind of weird. Yeah?
Its orbit, when it's closer to the sun, it goes faster. When it's farther, it goes slower.
Yeah, that is part of it. Exactly. Yeah, that's exactly right. So it is moving faster when it's closest to the sun. That's part of it. What else? It's pretty weird. So I guess it's closer to us when it's in front of the star too, which means that when it's behind the star, it's further away, and so there's more sun glare to get in the way of it, essentially. But yeah, it has these two different periods to it. Now, what's really weird is like the Sumerian myth, when they talk about the descent into the underworld of the Venus god, whose name was Inanna in the ancient Babylonian text, only 3 days they write in the book. I thought that was kind of weird. But I also was thinking about it, and it's like, sometimes, this might be a mistranslation, right? So sometimes sometimes we say a few, right? And a few could mean, or we say a couple, right? A couple of days. And a couple could mean 2, right? But a couple might just mean like, yeah, I'll see you in a couple of minutes, right? Maybe I mean 4 minutes, 5 minutes, 20 minutes, depending on how, conscientious I am. So maybe they just mean that the thing disappeared for a while, and they don't seem to discern between the long disappearance and the short disappearance, only that it does disappear. And again, they're telling this story of this goddess named Inanna, later known as Ishtar by the Akkadians. who has this dual role. So not only does she go through this really interesting descent into the underworld, where she's essentially invited to hang out with her sister who rules the underworld, and is eventually sort of captured and made to remain there and get stuck there. And the only way she gets her way back is essentially getting her boyfriend to take her place in the underworld. So she trades him out. But the goddess herself, Inanna, actually represents two different emotions, which is really quite interesting. She represents both love and war. So she's got this kind of like two sides to her already, right? This kind of like darkness and this light to it. Do you guys have any idea why in the world you would put love and war in the same god? Have you ever been in a relationship before? Yeah? Right? There's something really interesting about that, actually. I think that in some sense, like when if you find like really good long-term friends, really good long-term romantic partners, you get married, whatever. In some sense, like the best relationships are the ones that actually have a fair balance of chill and fight in them, right? So what do you want out of like a really good friend? You want somebody who's gonna like push back on you a little bit, right? Like one of the worst things that can happen to you is that you find yourself surrounded by people who just think you're awesome all the time and just laugh at all of your jokes and just bob their heads to everything that's going on. That might seem like fun for like a week or something like that. And likewise, if you get in a relationship with somebody, that might be fun for a year, maybe 2 years. But you really want somebody who's gonna push you to be a better person, basically, and call you out when you're doing the stupid things that you do, because we all do stupid things. And so I think there's something really profound about the fact that they embodied this Venus figure as both the god of love and war. 'Cause I think they really do go together. So, where do we go from there? By the way, another thing worth pointing out, you guys know where Sumeria is, right? Babylon? It's in Baghdad. Yeah. Which is really crazy if you think about it. This is kind of the birthplace of our Western tradition and all of our math and science. And honestly, we can trace most of our Western religions back to this place. And we just kind of bombed it into oblivion. But there it is, the birthplace of civilization. All right. The next people to take that up, to sort of pick up the mantle of the Venus myth was the Minoans and the Canaanites, who an argument can be made are kind of similar ancestry, similar culture, right? The Canaanites occupy what today is another super bombed out region, which is basically Israel and Palestine. And they're the ancient people all the way up through Lebanon too. And so the Minoans were on the island of Crete, which is a bit off camera here, or off the screen. And the Cretans, the Minoans, actually were a bit earlier in history, but they also seem to have had this bull at the center of their mythology. They had a number of different gods, and they had a god for Venus as well. And the god for Venus is quite interesting. So in the Canaanite version of the myth that I just told you about Venus descending into the underworld and fighting her way back up, they've actually, the Canaanites have taken that myth, which was handed down to them by the Minoans. And of course, remember, the Minoans were potentially a matriarchal society. It seems like there was a lot of female leadership in the Minoan society. And the first thing that the Canaanites on the mainland do after the Bronze Age collapse, and they inherit this myth from the Minoans, is they actually change Venus into a dude, which is really, really interesting. So the Canaanite god is named Attar, which is actually, and people kind of it gets confused in different regions. They're still using the female version. But yeah, they turn this into a dude, which is really quite interesting. So Attar, actually, it's this story of Attar wanting to dethrone Baal, who's like their central god down in the underworld, and fights this battle and loses, and Baal comes up again, right? So a very similar Descent to the Underworld story, conquering death in some sense, whether, again, like I said, whether that's actual death or whether it's just the kind of death of everyday life. It seems to be completely preserved story, which is just mind-bending that everybody's telling the same story. What else do I want to say? You guys have any thoughts yet? Yes, please.
When I'm thinking about Venus as like a goddess or god personified as both love and war, I guess I see like obviously like yeah like a really like in relation to our earthly relationships that they might both be necessary, but it also seems like this like almost like acceptance that like they're putting it on the same coin. They're putting both because they know that like to have one there you have to like pay the debt of the other.
Yeah, 100%.
Like this is the first planet that like
Danced out that story. Yeah, I think that's true. There's some really interesting psychological research too. I'm not just saying that stuff too. It's like they do these studies and they'll basically ask people how many positive interactions do you have, like on a score of 1 to 10 on a given day with your romantic partner, your spouse or whatever. And there's like a really there's an optimal zone for that with positive to negative interactions that you have, and it's like if you're too far in one direction and too far in the other, your chances at longevity go down dramatically. So if you have 0 negative interactions with your partner, your chances at longevity are almost nothing. If you have too many negative interactions, it's also really bad too. So there's this balance to be struck. And so in some sense, I feel like the ancient peoples were celebrating that balance. You still want to have a generally positive relationship. It's something in the neighborhood of like 9 to 1 interactions should be positive to negative with people in your life. But yeah, you can't have none either at the same time, right? So it's good to have somebody to fight with, turns out. You just don't hurt anybody. Thoughts? Yeah.
Well, okay, I kind of disagree with this
Yes,
a little bit.
okay.
I mean, like, I have to concede the fact that I'm 18 years old and have been in 2 long-term relationships. So I can't say, like, I'm the ultimate authority on this, but, like, it's so, like, I had a perspective like, oh, fighting is good. And then I was like, oh, that was a bad relationship. Now I'm, like, in that. And I'm like, now with my current partner, we don't really fight. And we've been together for a little over 6 months. We have like intellectual debates where we disagree.
Well, that might be sufficient. Yeah, fight doesn't have to be like a vicious, like, clawing each other's faces out kind of situation, I think.
Yeah, like I feel like people have this idea that like fighting is, I mean, it is normal. It's a normal like human behavior, especially if you're spending a lot of time together. Like
100%.
with like friends, I would. Like if I was going on a trip with a friend, like maybe we would fight because we were just in close proximity for such a long time.
Mm-hmm.
But I think there's kind of a thrill about like about the flip-flopping that people kind of get hooked up.
Oh yeah, that could be addictive for sure,
That,
for sure.
fighting a lot. And so I think that's, I don't know.
It's a balance to be struck. Yeah.
The notion that
Yeah.
like, love and war are. I slightly disagree. I mean, I can see the.
Yeah, well, it can get out of balance. I guess that's what I'm trying to reference. I'll try to find that study for you guys for next time. It's a really interesting quantifiable effect, right? And it's not necessarily about like vicious fights. Like one thing I would tell you, like, if you want to be in a long-term relationship with somebody, you should learn how to fight with them in a way that is not destructive to either your relationship or either one of you, right? You need to do it in a way that you have something left over afterwards, right? So like that's something that has to be worked out on an individual basis. But like by fighting, by war, I sort of mean that you're going to run into situations, ideally, because you're going to surround yourself with friends and relationships that are equally intelligent, smart people that they're going to think things should be done one way, and you're going to think things should be done a different way, and you're going to have to sort out which way is best. And that's the best kind of fight to get into, basically. And it doesn't have to be like a people are getting hurt kind of fight. And like, if you end up like, I've been with the same person for 13 years now, right? It's like, the worst thing that could happen is that I get into an argument with my wife where I've hurt this person, because the last thing you want to be married to is somebody that you've beat down, right? Like, you don't want to win in a fight because you don't want to be married to a loser, right? 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 You don't, though. Like, you don't. That's going to be horrible, right? You're going to have this person who's completely wounded. So, like, you have to learn how to do that and negotiate that and really open yourself up to the thought that even if you know you're right, that there's like probably 0.001% that you're not right about it, and you got to go figure that out and come back to it with like this way of meeting somebody in the way that you treat them like a real person who's smart and has valuable insight. And it's very difficult, but it is a wrestling match a little bit still. So yeah, I think there is something, especially when you're younger, that's very addictive. Like, I've definitely had those relationships where like just kind of like it's just like hot, cold, like, you know, just absolutely like dynamic and diabolical. That's not good either, right? So, and there's a lot of people getting hurt in that stuff too, right? But it can be addictive, and so I don't know. I mean, the whole saga, and of course, if you really unpack all the different sub-myths, especially the best preserved ones are the Greek ones, and there's pretty much a Greek myth for everything that's ever happened to you. Like, you just go to ChatGPT and just tell them what happened today and just be like, is there a Greek myth for this? They'll be like, yeah, I got you. So there's lots of nuance to the way that these battles play out, I think. But the fact that it is a central theme, I mean, this is, last thing I'll say is, it's just really interesting how these ancient peoples, they celebrated these stories that were commonalities. I feel like today, this world that we're living in, where we've tried really hard to get away from common mythology, it's like, how's that working for us? Like it's not. It can be a little bit isolating to not realize that everybody else is going through a lot of these same trials in their own nuanced, different ways. I think that the ancient people were really good about being like, no, we're all dealing with these things at different times and in different flavors, but we actually have a lot in common. And I think they use these myths to kind of like glue people together in their experiences that they're sharing. So yeah, there's nuance to it. War is not the same in all relationships, but it does seem to play out too. So, all right, we'll talk about it more next week. Have a great weekend, and yeah, live your lives.